Hello and welcome. Today we're going to learn about even and odd functions. If you look at the function on the left, this is an even function. The function on the right here is an odd function. Just like here. If we have, let's put these on the same page. So we have even functions on the left-hand side, odd functions on the right-hand side. You should be able to notice that the even functions are symmetrical because they reflect across the y-axis. Both of these reflect across the y-axis. The odd functions have rotational symmetry. So if I drew this, I'll do the best I can drawing that in, and there you go. Now if I take that and if I flip it 180 degrees, it'll come close to matching up with the function that I started with. Those are properties of the graphs of even and odd functions. Now, if we look at the equations of even functions, the equations of even functions only have even exponents. And that's including this -1, because we'll assume this -1 has x to the 0, which would make that an even exponent. The exponent on odd functions are all odd. So this is 3. If there's no exponent there, we assume that's a 1, which is also an odd number. So let's graphically, we know that even functions, why am I doing it like this? Even functions reflect across the y-axis. So I'll put in some points here. So if we have the point 1, 2, and 2, -1, and 3, 1, let's say. Now, if this function was an even function, it would have to reflect everything over here on this left-hand side. So this point would be in there. This point would reflect over. 3, 1 would reflect over. And despite my drawing abilities, this should reflect over the y-axis. Now, the definition says a function is an even function if and only if f of -x equals f of x. So we can take any point, let's say f of 3. F of 3 here is equal to 1. Now, if I take f of -3, 1, 2, 3, that answer is also 1. So what this definition is saying is f of 3 and f of -3 will give us the same answer. Here is the graphical representation. The numerical representation, remember numerical means table. If I have an x and y, if my -3 is 1, my +3 is also going to be 1. My -2 here is -1, so my +2 is -1. And that works out there. 1, 2 is a point on the graph, so is -1, 2. And 0, 1, there is a no -0, so that works out. Now, algebraically, we know that these two graphs have all of their exponents being even. So if we ever look at a function, we'll know that all of the exponents should be even. Now, on an odd function, it's a little bit, I think, a little bit more difficult because it's a 180-degree rotation symmetry isn't as easy to see. All right. So if we put the point 1, 2, 2, 4, and 3, 1 on here, and 0, 0. Let's just continue this down. If that's a function, if 1, 2 is a function, then -1, -2 is in the same function, if it's odd. If 2, 4 is a point, then -2, -4 is a point. If we have 3, 1, then we should have -3, -1. So this function would look something like this. So the definition being f of -x equals -f of x. Well, that means if we have f of 2 is equal to 4, f of -2 is going to be -4. Now numerically, it's going to look like this. We have -3, -1, -2, -4, -1, -2, 0, 0, 1, 2, 2, 4, 3, 1. Notice how we have -3, -1, so then we'd have 3, 1. -2, -4, so it'd be 2, 4. Now remember, the exponents of an odd function are all going to be negative if we see that algebraically. So if we want to complete this to make an even function, remember evens always reflect over the y-axis, so it'll just take this and reflect it over. Also, you can think that there's a point 3, 3, so there will be a point over here, -3, 3. And if you look at that, it's symmetric over the y-axis. Now if we want to make that an odd function, instead of going to the right 3, up 3, we're going to the left 3, down 3. And then fill in the last one. Now if I was to finish this drawing, like so, hopefully I can take that, and if I rotate it 180 degrees, it will be the same thing. And you can do that with your paper. You can just take your notebook and rotate it 180 degrees and see if it looks like your original function. Now if we want this to be an even function, we know this part here has to reflect over the y-axis, so that will look like that. This part has to reflect over the y-axis, so we're going to start here and come up to there. Now that's an even function. It's a little trickier when we look at the odd function, because here if we have the point 3, 2, then we'd have the point -3, -2. We can draw that part in. Here we have the point -3, 2, so that would be +3, -2. And then we have the point -7, 5. So we have the other point 7, -5. 1, 2, 3, 4. And there you go. Now we're going to do this tomorrow. That's the end of the lesson.